In this tutorial, we are going to learn about how to create a schematic symbol and PCB footprint for Atmega328P-AU, which is a SMD version of Atmega328P microcontroller. This microcontroller is more popular and widely used in Arduino Nano development board, which is again a smaller version of Arduino Uno development board, which consists of through-hole version of Atmega328P microcontroller. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. As always, this video is divided into 4 important parts. First one is understanding the datasheet and understanding the difference between different footprints available for SMD version of Atmega328P microcontroller. Second step is to creating a schematic symbol as per the datasheet recommendation using EasyEDA. Third step is to creating a PCB footprint by using the EasyEDA tool, in which we are going to refer the datasheet for mechanical information as well as dimensions, and again we are going to follow the Cartesian geometry and create a SMD version of Atmega328P footprint. Last but not the least, fourth step is to combine the PCB footprint and a schematic symbol to create a component library in EasyEDA. So let's get started. Now we can see that the datasheet of Atmega328P-AU microcontroller. It is available in 2 different packages. One is a TQFP package, another one is QFN package. This datasheet consists of all the details as a developer or a hardware design engineer or maybe the firmware developer should need. Of course, reading this datasheet requires a lot of time to understand all the packages and all the details, but what we are focusing now is all about the ordering information and the schematic symbol representation or pin diagram we can say, and then we are going to focus on the mechanical detail. First thing is, we can see a lot of features in this particular microcontrollers are listed on the first page, and then when we go to the pin configuration section, we can see that TQFP package is available and MLF package, which is also called QFN package, available in this particular datasheet. What we are going to refer for this tutorial is all about TQFP package, and notice this particular footprint design or a schematic symbol design is different from the previous tutorial, one in which this particular series of tutorials which we have covered is all about Atmega328P-PU, which is a through-hole version of this microcontroller, and it consists of 28 pins. Whereas this particular microcontroller consists of 32 pins and all the pins are not directly swappable or directly mappable. That's why you cannot use that particular schematic symbol for this footprint or this particular schematic symbol for the through-hole version of footprint. So that's why make sure that you create the schematic symbol once again. And when we scroll a little bit down or along down, we can see that ordering information is available. According to this datasheet, Atmega328P has 2 variants. One is MA variant, which is a package type, and another one is PN variant. Now we are going to focus on the TQFP, and based on that we are going to order the part number from whichever supplier we are referring to. And then when we go to the package information, here you can see that the MA version is the TQFP version, and all the mechanical dimensions are given in this particular table in mm format, which is unit of measurement is all about millimeters. And considering these all information, we are going to design our footprint in EasyEDA. This is all we need at this point of time from this datasheet. Again, when you are designing a product, you have to refer this datasheet in and out to understand a specific requirement of a specific part that you are using in your product design engineering. Now let's jump to the EasyEDA to start with a schematic symbol. Now we are on EasyEDA. Now I'll go to this file and create a new symbol. As we do for all the schematic symbols so far done in 14 tutorials previously, I'll be continuing with that without further explanation. Alright, now you can see that the entire schematic symbol is designed. First thing first, when we are managing the pins, it is very unknown to every one of us that which one is considered where. For example, if you are placing a PD0 here, then the placement of the text differs from the PC0 on the other side. Why? Because when you select that particular pin, you can see that the bracket information looks first and then the PC0 at the last. But when we are displaying, this is the right way to display rather than giving a PC0 at the beginning and then multiplexed information in a bracket later on, because that will come near to the pin and that doesn't look good. So considering such kind of aesthetic designs while designing a PCB footprint or maybe the schematic symbol is very essential. So pay attention to them, and when you are designing such kind of a complex microcontroller pins or maybe any components schematic symbol, make sure that you spend a good amount of time to paying the attention to the details. That is the very core skill of hardware design engineer. Now, one thing which we have not done so far is giving an electrical property to these all pins. While placing the pins, we should have given them, but I have not given purposefully, because what we can do is to reduce a repetitive work. We can select all of the same category pins. For example, the PD0 or to PD7, all are going to be GPIOs or maybe the IO pins. So when I select all of them and go to the electrical property and change it to the IO, this is the much faster way than changing it individual pin when we are placing the pin or giving a name to the pin. I'll do it for the VCCs as well, which is again, I think the border has got selected along with that. That's why it was not showing the details. Now here we have a power option coming to the ground. So I'll select all three of them and I'll give a power as the electrical property. And all of other side, they are all GPIOs, but among those, there are two pins. One is ADC6 and ADC7. They are only input pins. Pay attention to that detail. Why? Because this is very important. So I'll select both of them. I'll give them as an input only. And I'll select all of these. Above that ADC6. I'll select PC0 to PC6 and change the electrical property to IO pin. And again for PB series, I'll select all of them. I'll just deselect if anything is selected unintentionally. And I'll change the electrical property to IO pin. This is how we are going to change the electrical property of each pin based on the based on the property of that particular pin configuration. There is one more thing which is all about reset. Actually, this PC6 is a reset pin and it is an inverted pin, which is nothing but active low pin. That's why I'm going to create a dot on the outside so that we can get to know that it is active low, rather than just connecting a VCC to it will not reset the hardware. We have to connect a low signal or a ground to that particular pin to reset the microcontroller. So those bubble will indicate that particular property in digital design engineering. So that's why we have given that. Now we are done with referring the Moser electronics for the comparing the part number. Once I go to the Moser electronics, you have to copy paste the ordering part number from the data sheet that you are referring, and then you will get the manufacturer detail and the manufacturer part number. Perhaps the supplier part number is most important here, and also the details about the supplier. All that information, if you feed in the schematic symbol library, that is enough for us to conclude that a schematic symbol design is completed. Now it is time to go for the PCB layout. For creating a PCB layout, I'll go to the file and create a new footprint. Here comes the most important part and the most complex part so far in our entire tutorial series. Why? Because till now we have dealt with the one side pins and another side pins, which is dual inline package most of the time. We never dealt with the chord package. Chord package means we will be having a pin on the one side, another side, top side and bottom side. Like all four direction, we will be having pins. This is called chord package. That's why it is QFN package in most of the time, or TQFP also. So right now we are referring the TQFP and placing the pins as per the data sheet information. When you go to the mechanical details or the mechanical dimensions or package information of the data sheet, we can see that the body width and height is given to us, and the pitch from one pin to another pin of one edge to another edge is given to us, and also the width of the pin is given to us. Length of the pad should be computed from this value, which is L, and then we have to create a footprint for this. So let's start doing that. Alright, now you can see that all the pins are arranged properly. This is the first cord film package or maybe a TQFP package which I am designing live on my tutorials. I hope you understood the entire process. If not, feel free to comment down below in this comment section. I'll just reply back whenever I'm available. So first thing is, we assumed that the pad size is going to be 2.5 mm width and designed the entire thing. But when we kept it 2.5 mm, the one pad of the one side of the IC is getting overlapped with another pad, which is a problem. For that reason, what we did is we reduced the length of the pad or width of the pad, you can say, keeping the dimensions same. We have never changed the Cartesian geometry from one pad to another pad or the pitch for that matter, because we cannot change that because our IC is getting manufactured with that dimension and we have to follow it no matter what is the reason. But we can increase and decrease the soldering pad ka width as per our convenience. The smaller it is, best one it is for the better soldering. But in case of debugging or any kind of rework activity, it becomes very difficult to handle with a small pad. That's why it is choice of a designer to choose what length of a pad is required as per the design application or the requirement of the customer design and actually. So right now I'm considering the professional manufacturing and I have given the pad width for 1.5 mm. You can go up to 2 mm and reduce the inner border which we have drawn with the top silk layer using the yellow color border line. You can reduce it a little bit inside and make it even more little smaller and go with the 2 mm pad width. But right now I'm good with 1.5 mm. The most important thing is the pitch from one pin to another pin. You can consider here, I'll go to this point and I'll measure the distance from this point to this point is going to be 9 mm, and from this point to this this point actually, it's going to be 9 mm. This is very important. Why? Because when we refer the data sheet, you can see that in package information, the distance from one edge of the pin to the another edge of the another pin is going to be 9 mm. It's given here, D, right? D or E is going to be 9 mm. If you maintain this distance from both the side, then whatever aesthetical changes or pad differences that you are going to do is not going to matter at any cost, because it's your personal choice. So this is how our entire TQFP SMD cord pin IC footprint to be designed. Alright, now it is time to combine the schematic symbol and PCB footprint to create a component library. That process is very straightforward. For that, we need to go to the schematic symbol that we have designed just now, and just to ensure once again, make sure that all the pin number that you have given are in sequential manner and they are given in a proper region or proper path. Why? Because if you start pin number 1 from this direction and travel all the way around in a clockwise direction, that becomes the big blunder in your entire component library design, because that's going to make a lot of difference in entire hardware design engineering. Instead of that, make sure that you are given a number in a anti-clockwise direction, for example 1 2 3 4 5 6 all the way down, and then from there on the right side and going to the top side, because it will make a lot of difference in case of practical design engineering. Now we know that it is right, so what we are going to do is we are going to go to the schematic symbol, click on the footprint section and search for TQFP-32P, which is a given name to it. I think it is not P, probably 32 only. Alright, it is TQFP_32P. It's not -32P. So difference in characters and symbol, right? So once we select that particular footprint, you can see that our schematic symbol is associated and attaching the all pins to that particular footprint. I'll just double click on that footprint search result, or maybe I'll click on the update footprint, and now we are done with creating a component library for Atmega328P-AU. Super duper. I believe that you have enjoyed and understood the entire process of how to create a schematic symbol and PCB footprint for Atmega328P-AU microcontroller IC. The most important takeaway from this tutorial is all about creating a cord package footprint. which is all about TQFP or maybe QFN package. The dimensions and mechanical details are pretty straightforward. Only thing is Cartesian geometry that you have to understand and use them strategically. I believe you have understood everything. If you have any questions or any concerns or suggestions, feel free to comment down below in this comment section. Consider subscribing to our channel Linked Frequency and share it with someone who may need it, so that it helps us to grow in the community of engineers. Thank you so much for watching this video. See you again in the next one. Until then, tune yourself to make a difference.